Hello everyone, welcome back to my YouTube channel. Today we are going to discuss about the Faraday's law of electromagnetic induction. So what is Faraday's law of electromagnetic induction? First of all, we have to understand by a figure. So this is a figure where a bar magnet and a conducting loop and a galvanometer is connected at the ends of the conducting loop, and the bar magnet is placed along the axis of the loop. When when we when a bar magnet moves towards the conducting loop, a small induced EMF is produced in the loop due to this bar magnet, and which shows a deflection in the galvanometer. And when bar magnet moves away from the conducting loop, again a induced EMF is produced but in the opposite direction. So by a number of experiments, Faraday discovered that the behavior of magnetic field by a number of experiments and discovered the following law of nature. So whenever the flux of magnetic field linked with the area bounded by closed conducting loop changes, an induced EMF, which is electromotive force, is produced into it, and the magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux. So EMF, which is written by E equals to minus d phi by dt, where d phi is the rate of change of magnetic flux, phi is the magnetic flux, and negative sign indicates that the induced EMF due to changing flux always opposes the change in magnetic flux, where phi equals to integral of b dot ds, where b is the magnetic field and d is the small area vector ds. B dot ds is the flux of magnetic field through the area, and its SI unit is Weber or Tesla meter square. So as long as the magnetic flux keeps changing, the EMF is produced. So in how many times we moves bar magnet towards or away from the conducting loop, the EMF is present into it and flux is induced. The EMF produces electric current in the loop, and induced current in the loop is I is the induced current, and I equals to E by R, where E equals to EMF and R is the resistance of the conductor. I equals to E by R equals to 1 by R d phi by dt, where minus d phi by dt is the EMF and I equals to minus 1 by R d phi by dt. If the flux increases with time, then d phi by dt is positive, and E, which is electromotive force, is negative. And if the flux is increases with time, then E is negative. From correspondingly the current is negative.